Hey, welcome to Questpoint's YouTube channel. And what are we doing today? Today we are going to go and walk through 30 important C# interview questions, or I'll say 30 important .NET interview questions. So this is part one of the video series. And in this whole video series, we will go through some fundamental C# questions. Fundamental means like CLR, garbage collector, CTS, stack, heap, reference type, generic collections, multi-threading, try-catch block, delegates, events, difference between abstract class and interfaces. Remember that if you're not able to answer the basic questions, for example, if you're not able to talk about what is a stack and a heap, what is boxing and unboxing, it is very rare that your interview can continue for a long time, or it will have any positive results, right? So please ensure that the fundamental questions, should be right, flowing from your head. The answer should come out very fluently. And also very quickly, I would request everyone to visit my site questpoint.com, where we have a lot of videos, advanced video tutorials. So like, for example, if you want to learn Angular, if you want to learn MVC, if you want to learn Cloud Azure, if you want to do interview preparation like .NET interview questions and Angular interview questions, Azure certification, microservices, design patterns, Azure architecture training, right? So you will find a lot of videos out here, more than 1,000 videos, which are like step by step, which are important from the career perspective. So please do go and visit my site questpoint.com. And also I would like to announce a small gift out here. If you go and if you share this video somewhere on your LinkedIn profile or on your Facebook profile or on your Twitter profile, right? This ebook, we are circulating for free. So you can see this is a 100-page ebook, which basically has lots of questions, which are around the basic .NET fundamental things. So, .NET framework, then, IL code, CLR, CTS, value type, reference type, garbage collector, and so on, right? So if you go and if you share this video tutorial on LinkedIn or on Twitter or somewhere, right, and send us a mail at questpoint@questpoint.com, this ebook we will deliver to you in your email. So let us get started. Let us get started with the first question from our 30 questions. Explain the difference between .NET and C#. Now, this question won't be asked directly by the interviewer. So the interviewer won't be asking you, explain me the difference between .NET and C#, but it is very much possible that, during the interview conversation or during the interview discussion, never ever get into a situation, wherein you say .NET and C# are one and the same thing. It will create a negative dent in the interview, right? So here is the answer for this. .NET is a framework and C# is a programming language. I repeat this. .NET is a framework and C# is a programming language. When you talk about C#, it has those syntaxes, it has those grammars, it has those semantics, it has those for loops, it has those if conditions. So C# is a programming language. It is Microsoft's flagship programming language. While .NET Framework has two things. It is a collection of libraries and it has a runtime. So let us first start with collection of libraries. So you can see here in my Solution Explorer, there is a framework. So for example, you say that I want to use a collection. So if you see in C#, we can go and we can use a list, right? So we can use a list. So for that we have to use this systems.collection. So if you go here, this system.collection is a ready-made component, a ready-made library. So if you go here, if you say right click properties, you can see the system.collection. It is a library. So I can go here, Control R, Control V, and you can see there it is system.collection, right? Or if you say something else, I'm sorry, if you say something else, for example, you will say that I want to go and use XML. So you can see system.xml. And if you see here, if you go to the path, you will find a system.xml DLL. So, all these things, what you saw now, all this like system.console, system.core, system.data for ADO.NET is all reusable libraries which belongs to .NET Framework, right? And also .NET Framework has one more thing. It helps you to run your .NET application. It has a thing called as CLR. So it has those CLR, it has the garbage collector, it has the CTS, the CLS. So when you run your .NET application, this is again the work of .NET Framework. It goes, it kicks off the CLR, it compiles your application, and it makes your application running. So please note, there is a very big difference between .NET and C#. C# is a programming language. It has the syntaxes, it has the semantics, it has the grammars, it has those source code, while .NET Framework is a collection of libraries as well as it helps you to run your .NET application, right, or C# application. And using both of them, we create an application. So you will use C# and you will invoke the .NET Framework libraries. Right? So from C#, you will go and you will invoke the .NET Framework library. So you'll say, okay, I want to go and create a list of a string. So C# is a programming language and it will invoke the .NET libraries, and .NET will also has a thing called a CLR to make your application running. So in the interview, whenever you are talking with the interviewer, always send a message to him saying that yes, .NET is a framework and C# is a programming language. Differentiate between .NET Framework versus .NET Core versus .NET 5.0. Now, please note, that when this question comes during the interviews, there are more than 10-15 differences which you can see highlighted out here. But try to put down the first one or two biggest difference between them. Right? So do not try to just go and start, speaking all the 10-15 points. It would look very, very one-sided, right? So the first thing, which should really, really come out very strongly is that .NET Framework, which is our old one, which was created 18 years back, only works for Windows. While the .NET Core is cross-platform. So it works on Linux, it works on Mac, it works on Windows as well, and so on, right? While .NET 5.0 is the unification of both of them. So you can say that .NET 5.0 has, it has all that good things, what you did, for the past 18 years. Also, it has those new features, which are coming in .NET Core, right? So .NET 5.0 is more of a unified platform which unifies not only the .NET Core and .NET Framework, but it unifies a lot of other .NET runtimes. Remember that there are a lot of other .NET frameworks, like Mono, and something we made for Silverlight, and then we made something for, other things, right? .NET Compact and so on. So basically, .NET 5.0 unifies .NET Framework, .NET Core, .NET Mono, right? And so on. Why? Because that you get a common experience. You get a common experience because what is happening now, if you see what is happening now is, if I want to go and create a project, let us say that I want to go and create a project in .NET Framework, then I need to go and see that, okay, like what I want to do, I want to go and create a project in, let's say, console application .NET Framework. Okay, so console, and then I have to go and choose, saying that, okay, here is .NET Core no, .NET Core VB no, .NET Core Framework. So I have to go and make a choice. This is not a unified experience. You have to go and choose, saying that, okay, I want to select a .NET Core template, I want to select a .NET Framework template, and so on, right? So the goal of this .NET 5.0 is to provide a unified experience, to provide a unified platform which unites all the .NET runtimes around the world, one which is coming from Microsoft, .NET Framework, .NET Core, Mono, right? And provide a unified experience, right? So this is the first thing which should really come out. I repeat this, .NET Framework is the classic one, the old one. It works only on Windows. .NET Core works cross-platform, and .NET 5.0 is a unification platform which unifies all the .NET Framework into one umbrella, giving you a unified and a common experience. The second point, which I feel you should talk with the interviewer is performance. performance of .NET Core is better than .NET Framework. Now, what is the reason for it? If you see .NET Framework, for example, you can see here I have this two application, the Console App 23, which is .NET Core, Console App 1, which is .NET, right? So if you look at the .NET Framework, we had big DLLs, right? Big components, right? Like system.data, and then system.data had the entity framework, system had the collections as well as a lot of things, so you can see here we have like 1 2 3 4 5 6 7 8. I can just count it on my fingers, right? But when I look at .NET Core, you will see like, oh, they are broken down further again. Like for example, system.collection, you want system.collections.specialized, then you can go and say system.collection.specialized. So you can see that .NET Core they have taken that big DLLs of .NET Framework, and they have broken down them into small pieces. Now what happens because of this? Whenever the components are loaded, they are loaded only what we need, first thing. Second, the memory footprint because of this becomes less. Because we are loading only what we need and not loading the unnecessary things, the memory footprint becomes less, and if the memory footprint is less, then definitely the performance becomes better, right? So .NET Core performance is better, because they have divided the big DLLs into small pieces. So you can just say, okay, I want system.collections.concurrent. That's it. I don't want other things. So he will only give you concurrent and not the rest of the things. But in case of .NET Framework, if you say, if you want collections, then it is system.collections. That's it. It has a list, it has this, it has the stack and so on, right? But here, they have broken down into small pieces, right? So this is the second thing I feel which should come out when you are speaking the differences. And the most important one which I will speak from all of these 10 points is CLI support. In case of .NET Core, right, you can go and you can fire commands through the command line. For example, here you can see this is an .NET Core application. So I can go to my command line, and I can go here and I can fire from my command line like .NET build, .NET run. Now what happens when you can fire things through command line? You can see that it has some exceptions out here, but the point is that I can go and I can fire commands through my command line, right? Now what is the advantage of it? What is the advantage of firing through command line is that I can integrate with any IDE. I can even code in a simple notepad. But when it comes to .NET Framework, right, you don't have too many choices. You have to literally go only through Visual Studio. You have to go through that templates. If you want to create a project, you have to go through templates. Over here, what you can do is, you want to create a project, you can say .NET new console, and it goes and it creates a console application. At this moment, yes, I already have a template, so I can't do it, but you can go and you can create projects, you can run projects just through the command line, and that makes again .NET Core more attractive. Why? Because you have a CLI support. And .NET 5.0, remember I said is the unification of all the .NET runtimes. So first thing, when this question comes before you in the interview, there are 10 differences, as I've already said, but I would say that pick your 1 or 2 or 3 difference and put before the interviewer. Now if the interviewer asks you further, right, if he says that, okay, like, can you tell me if I want to develop microservice, is .NET Framework good or .NET Core? Must be, then you can talk about the other difference, right? If he asks you saying that, okay, like, is packaging better in .NET Framework or .NET Core? Yes, in .NET Core, because here it is more modular, more smaller in size, small pieces, you can plug them together, right? But here it is like one big framework, makes things difficult, right? So 3 big differences: cross-platform, performance is better in case of .NET Core, and CLI tools. .NET 5.0, you can't really talk about the difference because it is a unified platform, right? It unifies all the .NET runtimes, right? One which is of Microsoft, as well as one which comes from the community like Mono and other things, right? The next thing is, because of that, you have a common experience or a unified experience. What is IL code and why do we need JIT? Now let me answer both of these questions in one go, because both of these questions have a very, very deep connection, right? So first thing, when you say that your C# code has to run inside a computer, it has to be converted to an assembly language, or it has to be converted to a machine code, right? Or it has to be converted to a machine language. So this code out here of your C#, whatever you have here, if it has to go and run inside a computer, right, inside a machine, it has to get converted to an assembly or into something which the machine understands. So machine language. So this is your higher level language, you can say, right? So when the compiler compiles, it has to get converted into this machine language. But what C# compiler does is, it does not directly convert this into the machine language. It first converts it into a partially compiled code called as IL code, or the intermediate language code, right? So IL code stands for intermediate language code, and it is a partially compiled code. And later on, when you run your program, right, when you say that, okay, now I'm going to go and run my program, I'm going to go and execute my program, at that time, we have somebody called as the JIT. So this JIT, which stands for just-in-time compiler, runs over this IL code and compiles it into the machine language, right? So what is IL code? IL code is nothing but an intermediate language code. It is a partially compiled code. What is JIT? JIT stands for just-in-time compiler, right? And this just-in-time compiler actually goes and compiles this IL code into machine language. Is it possible to go and see this IL code visually? Yes, it is possible to see this IL code visually by using disassemblers like ILDSM or ILSpy, right? So for example, you can see here, this is my compiled code here, which is a DLL, dynamic link library. If I want to go and see this, I have ran ILDSM, right? So you can see this is ILDSM, which is a disassembler which comes with the Visual Studio command prompt. So over here, if I go and I can go and I can see this add method out here, which actually adds two numbers. It actually adds two numbers. So if I go here, I can see that this is the code here, right? This is IL code actually. You can see that it takes two numbers, right? It does addition of the two numbers. So these are the two numbers, arg1, argument 2, and it does the addition of these two numbers, right? So yes, it is possible to go and see the IL code visually by using disassemblers like ILDSM or ILSpy. What is the importance of compiling into IL code? Or I will say rather, why do you want to go and compile into an IL code? So here, what the interviewer wants to ask you is that, so this is your C# code out here. Why do we have to go and compile it into a middle language like IL code? Why can't, just like C or C++, compilers, wherein directly they go and compile into machine language and assembly language? Why can't we do the same with C#, right? So the reason for this is the difference between the development environment and the runtime environment. So over here, for example, now this is your C# code. Let us say, the developer is using Windows 10, right? Let's say he's using Windows 10. He is using a 64-bit machine and so on, right? But, the runtime environment out there, can be Windows 8. It can be, must be Windows XP, who knows, right? Or Windows 7, right? And nowadays with .NET Core, we are talking about this can be Linux as well, right? So the runtime environment can be very different. So this is your dev environment, right? The developer's machine, right? Which can have a different environment, a different operating system, and this is the runtime environment. So because of that, what .NET does, it first goes and compiles it into IL code, and then the JIT, depending on what is your OS, right? He says, okay, what is the best code, for Windows 8, optimized code? What can be the best code, which can be generated for Windows XP, or the best compilation, I mean, and for Linux and so on. So that's why, we have an IL code. So over here, probably, to put things together, the runtime environment and the development environment can be very different. So that's why, we go and we compile into IL code. Then depending on what kind of environment it is, JIT goes and generates or compiles an optimal code as per that runtime, as per that operating system, as per that hardware of that execution, execution environment. Does .NET support multiple languages, right? Multiple programming languages. So in other words, here the interviewer asking you is that basically, can I just go and write my code only in C#, or there are other languages with which .NET Framework supports, right? So .NET Framework supports many other languages. For example, when you go and you create a new project, you can see that you can write your code in C#, you can write your code in VB.NET, you can write your code in F#. This is again one more language. You can see F#, and we have other ones like, VC++.NET and so on. So remember that .NET Framework supports multiple languages, like VB.NET, C#, VC++.NET, F#, and so on. But at the end of the day, either you code in C#, either you code in VB.NET, right, or Visual Basic, at the end of the day, it will get compiled to IL code. So it does not matter, what is your programming language. You like these curly brackets, right? So for example, the whole point of creating this multi-programming kind of environment for developers is that some developers like, C#, because it is case sensitive, because it has those curly brackets, So if you are a developer who likes, well, let me add. So you can see I've added VB.NET. Let me also just very quickly go and add C# out here. If you're a developer, who likes, to code in this curly brackets, who likes things to be case sensitive, go ahead, C# is for you. If you're a person, who has started your career in Visual Basic 4 and Visual Basic 6, and you like, this verbose code, you don't want case sensitiveness, so then go for VB.NET, right? So the .NET Framework, supports multiple programming languages, but at the end of the day, it gets compiled to IL code. So the answer here is yes, .NET Framework supports multiple programming languages, but finally when it starts executing, it compiles to IL code. Explain the importance of CLR. CLR stands for Common Language Runtime. Common Language Runtime. It is the runtime execution environment of .NET. So CLR helps to execute your .NET application. So there are two primary things, the CLR does. First, it converts your IL code to native language or to machine language. So this is the first work of the CLR. Second, this native language, whatever the native code, right, it goes and it executes it, it runs the application, right? And when the application runs, any kind of unused memory of the application is consumed by something called as a garbage collector. So CLR is also responsible to run the garbage collector. So CLR primarily does two important things. Actually it does a lot of things, but here, for the interview, I'm just highlighting two important things. One is it converts your IL code to native language, right? Second is it runs your application, and when your application runs, if there is any kind of unused memory, right, that is claimed by this garbage collector. So running of the garbage collector is also part of CLR. What is the difference between managed code and unmanaged code? Code that executes under the environment of CLR is called as a managed code. So all the code, what we write in C# or we write in VB.NET, right, which gets converted to IL code is all managed code, because the CLR compiles it to the native language. The garbage collector collects, when the objects are not used. So basically, the code, which runs under the umbrella or under the control of CLR environment is a managed code. Like example here, this customer X equal to new customer, this static void main, this class program is all managed code. But code which does not run under the control of CLR execution environment, for example, C++ code or VC++ or VB6 code. For example, in this code, you can see I'm importing a user32.dll. And this user32.dll probably is made in C or C++ or VC++ or whatever, right? So they have their own compilers, they have their own runtimes. CLR does not control them. So these kind of code are unmanaged code. So for example, in this program, when I run this program, right, if I run this program, it will pop up a message box, but that message box, whatever is coming out here, is coming from some other C++ or VC++ or C kind of a code, right? So if you see here, this console application is all .NET, right? But you can see this message box here. Where did the message box go? This message box here, hello world, right? That's not coming from C#. It is coming from the user32.dll, which is probably written in some other language. So managed codes are those codes which run under the control of the CLR execution environment, and unmanaged codes are those codes which run outside the CLR execution environment like C++ or VC++ or VB6, and they have their own compilers, they have their own runtimes, they have their own way of doing the memory allocation. Explain the importance of garbage collector. Garbage collector is a background process which keeps running continuously and claims any kind of unused managed resources. I stress this two words, unused managed resources, right? So if there is any unused managed resources while your .NET program is running, garbage collector comes now and then and starts cleaning them up. For example, you can see here, I have a very simple program which is a for loop, which is running for a very long period. So this is creating customers and then, disposing them. This is creating customers. New fresh customers are getting created, right? Customer objects are getting created. So now what will happen is garbage collector will come, after some time, right? Undeterministic time, it will come and it will clean these objects. So if you see out here very quickly, we can just see this in the profiler. So you can see here, this profiler will help us to show or help us to show that when the garbage collector runs. So you can see here very quickly, I'll just zoom in, right? You can see first the memory was rising, so new customer objects were getting created, but after that you can see now garbage collector, these small red signs out here, you can see garbage collector is running, gc count, gc count, gc count, and you can see now the memory is flat. So the objects are getting created and the objects are getting collected, right? So very quickly in the interview, just remember garbage collector is nothing but it is a background process which keeps running continuously and claims any kind of unused managed resources. Can garbage collector claim unmanaged resources? Unmanaged resources means objects which are created by C++ or objects which are created by some other programming language. The answer is no. Garbage collector cannot collect objects which are created outside the CLR runtime. Explain the importance of CTS. CTS stands for Common Type System. Now .NET is a framework and it supports many programming languages. So you can invoke the .NET library using C#, you can invoke the .NET library using VB.NET, F#, VC++.NET, VF.NET. So there are many programming languages out there which can compile to IL code. But now each one of these programming languages, when they define their data type, they have their own way of doing it. For example, you can see on the screen, I have C# out here. In C#, when we define a data type, we say int I equal to 0. And in VB.NET, we say dim I as integer, right? And in VC++, we can say some other way of doing it. Or in F#, we have some other way of declaring the data types. Now, suppose that I want to go and use this VB.NET code inside C#. Then how do I go about it, right? There should be some common platform because the data types are so different of each languages. So what the .NET compiler does is, or when the compiler is compiling the code, it compiles them into a common type system. So it says that, okay, your VB.NET says dim I as integer, C# says int I. Both of them get compiled into a common type system, which is int32. So in the same way for other data types, if you have string, if you have char, if you have double, if you have decimal, right? So common type system ensures that, whichever language you code in, at the end of the day, your data types, will get mapped to a common data type of the .NET framework. Explain the importance of CLS. CLS stands for Common Language Specification. So .NET supports multiple programming languages, right? Now these programming languages are different in terms of data types and also behavior. So the data types difference is handled by common type system, right? But the behavior also of the languages are different. For example, let us say in C#, C# is case sensitive. So in C#, if you say int I equal to 0, small I equal to 0, and int capital I equal to 0, both of them are different. They are different variables, right? But in case of VB.NET is not case sensitive. So if you say dim I as integer, small I as integer, and dim capital I as integer, both of them are, you can't have like this in VB.NET. You will see that you are getting an error, right? So now think about it. If you write a C# code something like this, where there is I and capital I, how can VB.NET understand it? Because he does not understand case sensitiveness. He says that for me, I is I, either capital I or small I, right? So some languages, is case sensitive, some languages is not case sensitive, some language is functional, some language is not functional. Some languages uses pointers, some other languages don't use pointers, right? So if they start using their own custom behavior which is not existing in other languages, it will become very difficult to have cross interoperability. So in other words, if I want to go and consume C# code inside VB.NET, it would be difficult, right? So the common language specification is set of guidelines, which says that, okay, guideline number 1, don't use case sensitiveness. Guideline number 2, don't use pointers. Guideline number 3 and guideline number 4. So if you follow those guidelines, then inside your .NET environment, you can easily consume a VB.NET code inside C#. You can consume an F# code inside C#, a C# code inside F#. You can have cross interoperability between the languages. So I repeat, common language specification are set of guidelines. If that is followed, then the languages, the code what you write in different languages, can reuse very easily, can reuse seamlessly, right? While common types system, which we discussed previously, is nothing but, when the data types of the languages are different. So common type system more deals with data type, saying that, okay, integer, dim I as integer, and int I, let me bring them into a common platform, right? So CLS deals with different behaviors of the language, while CTS deals with the data types. Explain the difference between stack and heap. Stack and heap are memory types inside .NET application. So when your .NET application runs, there are two memory types. One is a stack and another one is a heap, right? On stack, primitive data types are allocated. Primitive data types means data types like integer, boolean, double, decimal. So these data types, get allocated on the stack, right? And on the stack, the variable and the value both are stored at the same place. For example, you can see this first statement out here, int I equal to 0. So here, the I will be stored in this location, and also the value 10 will be stored in the same location. Second one, boolean b. So in stack, it goes like one above another. So look at the second variable, boolean b. So here also this b will get stored here. The memory location is the same, where the value is. So the value true is also stored in the same memory location, right? So in case of stack, the variable and the data and the memory location all are at one place, right? But now look at the third thing here. This is an object. You can see that we are creating a customer object with the value shiv in it. So in this case, the X will be allocated here, yes, the X will be allocated, but the value will be stored in the heap. So this value, whatever you have here, name equal to Shiv, will be stored in the heap. So in X, here only a pointer will be there. So there will be a pointer here, and that pointer will point towards the actual customer object X, right? So in heap, objects are stored. On stack, primitive data types like integer, boolean, and other things are stored. So stack stores primitive data types while heap stores objects. What are value types and what are reference types? Value types are those types which are stored on the stack, and the value and the pointer, means the memory location, both are stored at the same place. So for example, you can see here this int I equal to 0, I equal to 10. The memory location and the value, they are both stored at the same place. Same way, look at b equal to true, right? Reference types are those types wherein the pointer is stored on the stack, but the actual data is stored on the heap. So the actual data is stored on the heap. So there is a reference out here. So in reference type, the memory pointer is stored on the stack, but the actual data, like this value Shiv, is stored on the heap. What is the concept of boxing and unboxing? Boxing is nothing but it is when your data moves from a value type to a reference type. So you can see here in this code, we have integer I equal to 0, which is a value type because it is allocated on a stack. You can see that we have object Y here. So now we are trying to move this value I to Y. This is termed as boxing. When you're moving from a value type to a reference type is termed as boxing. When you're moving from a reference type to a value type, it is termed as unboxing. So you can see the next line out here is unboxing because you're trying to move from a reference type to a value type. The next connected question to boxing and unboxing, which normally the interviewer can ask you, is that what is the consequence of boxing and unboxing? The consequence of boxing and unboxing is performance, because now your data is jumping from a value type to a reference type. It is jumping from the stack memory to a heap, and then you are jumping from a heap to a stack. So if you are doing this more and often, right, definitely you will have a performance implication. Explain casting, implicit casting, and explicit casting. So first thing, let us try to understand what exactly is casting. Casting means you are trying to move from one data type to another data type. For example, you can see this is integer I here, and you are trying to move from integer to a double data type. This is termed as casting. Now, if casting is happening automatically, means you don't have to do anything, then it is termed as implicit casting. You can see over here, I don't have to do anything. I have to just say I equal to D, and the value will move from integer to the double, right? So when you are moving from a lower data type to a higher data type, you will normally have implicit casting. So like when you're trying to move from an integer to a double, so integer is a lower data type and double is a higher data type, this is termed as implicit casting. But now let us say that if you are moving from an higher data type, so let's say here it is 100.23, and if you want to now move towards integer, so you want to move now from a double to an integer, you can see it is showing me an exception. So it is saying me that I cannot cast this automatically. You need an explicit conversion, an explicit casting. So over here I have to go and say int. So this is termed as explicit casting, right? So casting means you are trying to move from one data type to another data type. Implicit casting means you don't have to do anything special. The value just moves from one data type to another data type. While explicit casting means you are trying to move from a higher data type to a lower data type, and you need to specify the data type before the variable name like this. So what is the consequence of explicit casting? The consequence of explicit casting can be data loss, right? So for example, here now in this case, because there is no data loss, C# just allows you to do the casting. But in this case, you can have a data loss because integer does not support decimals. So here we will have a data loss. That's why to make you, to alert you, it is telling that, hey, do you want to do this? Do you want to really lose the decimal part of it? I'll say, yes, I want to lose the decimal part of it. I understand, what I'm doing. So explicit casting is like a warning, saying that you are going to have a loss of data. Are you sure about it? So if you see, for example, if I run this program, you will see that in the Y, I will not see the decimal part of it. And this is Y. Right? So you can see this is D, this is Y, right? So this is 100.23, which is into D1. Now from D1, when I move to Y, you can see that he has removed the decimal. So here we have a data loss. So in explicit casting, there is a possibility of data loss and we should be careful about it. What's the difference between an array and a array list? So an array is a fixed length size. So you can see here that this is the array here. It has 3 elements. So it is a fixed length size. You can go and resize an array, but it is quite of a ceremony. So for example, I can go and I can say array.resize. So you can see this resize method again belongs to someone else. It belongs to an array. Then I have to go and pass in my array. So you can see that it is quite tedious, to go and resize an array, because the whole goal of array was its fixed length, right? So array is fixed length. That is one part. Second, it is strongly typed. In other words, now this array is very specific. It is a very specific type of integer. So that means that in this M array, I cannot go and push here string. I cannot do this. So you can see here I'm trying to push a string. It is not allowed. So array are fixed size, fixed length, and they are strongly typed, right? When it comes to array list, it is flexible in terms of number of elements. So I can go and I can say here mylist.add 1. I can then say mylist.add 2, and I can say mylist.add Shiv, right? So first is the size is flexible when it comes to array list. The second important thing is it is not strongly typed. So it is not strongly typed. You can see here, you can see it down below, not strongly typed, right? You can see down below, I can go and I can add a number, then I can add a string, and then I can add a boolean, I can add an object, right? So the difference between an array and an array list is array is fixed size, array list is flexible in terms of size. Arrays are strongly typed while array list is not strongly typed. So after this, definitely a connected question which will come is, in terms of performance, is array list better or is array better? So when it comes to performance, definitely array is better. Why? Because it is strongly typed. If you look at array list, I can add a number, I can add a string, I can add a boolean, and so on. So that means I can add anything in my array list. So this leads to boxing and unboxing. So for example, when I'm adding value 1 out here, so that means I'm actually moving from a value type to an object, to a reference type. If you see here in this my list.add, this add is taking an object. So basically I'm moving from a value type to a reference type. So that leads to boxing and unboxing, and because of that the performance of array list is not good when it comes in comparison with array. But remember that array list has a flexibility, so the size is flexible, so that but that comes at a cost. The performance is comparatively slower when it comes to array because of boxing and unboxing. What are generic collections? Generic collections takes all the good things of the array and takes all the good things of the array list. So what is the good thing about the array? It is strongly typed. What is a good thing about an array list? It is flexible. So in a generic collection, I can say like this, I can say list. Now this is a generic collection, list of integer generic int equal to new list of integer. Now this is a generic collection. So you can see here now, first it is strongly typed. So if I do an add, you can see now this is pure integer collection, right? So I cannot go and add a string out here. So that means all that boxing and unboxing all has gone off. So I can't go and add this, right? It is not allowed. It says that no, you cannot convert a string to an int, right? And the second is I can go and I can add any number of elements, so it is flexible. So a generic collection is strongly typed, that is one, right? And also in terms of size, it's flexible. So when it comes to using collections in .NET, the favorites for everyone is a generic collection. And so you can see this is a list of int. In the same way, I can go and I can create a list of Boolean, right? So this is a list of Boolean. Now this generic collection becomes a strongly typed Boolean collection, right? You can see now it's a Boolean collection, right? So a generic collection is strongly typed and also the size is flexible. So it takes all the good things of the array. That means it takes the strong typeness of the array and it takes the flexibility of the array list. And when it comes to .NET, this is the most used type of collection. What are threads in C#, or how to implement multi-threading in C#? Multi-threading or threads in C# helps you to execute code parallelly. So if you want to go and do parallel execution of your code, then you need to use threads. So for example, you can see in my code out here, we have method 1, we have method 2. So now if I want to go and execute both of these methods parallelly, then I need to go and create a thread. So you can see that I'm creating a thread, new thread and method 1, thread T1, a new thread and method 2, and then we say t.start and t1.start. With this, what happens is both of these methods will run parallelly. And to implement threading, we need to use the namespace system.threading, right? So you can see here, if I run this code out here, it will run method 1 sometimes, it will run method 2 sometimes. So you can see out here, it is running sometimes method 2, it is sometimes running method 1. So if you want to go and implement parallel execution, or if you want to go and run your code parallelly, then you need to go and use threads. What's the difference between thread and task? What's the difference between system.threading and task parallel library, right? So in other words, if you see in .NET 4.x, there was something released called as task, TPL, task parallel library. So you can achieve the same thing, what you can achieve by threads. For example, the same code, what I've written here, I can just use task like this and task and task, and this code will also run parallelly. So the interviewer is trying to understand that what's the difference between using a thread and using TPL. Now, before I answer this question, I want to share a very important tip. In C# interviews, in .NET interviews, or any interview, I'll say rather, always answer to the point. And when you get such questions, like explain the difference between this and that, right? Always answer important things first. Do not hit around the bush. I repeat this, do not hit around the bush. Interviewers are mostly seniors. They are already stressed in projects. They do not get paid extra for interviews. And on the top of it, if you get some candidate, who is just taking him around, it's not going to help. So for instance, in case of threads versus task, probably, if you tell him that, okay, like TPL has async and await, must be it will not convince him, right? So let us try to answer this question. Let us try to answer the important points first, when it comes to differences. So the first big difference between thread and task is that task does parallel processing. The name itself of task or TPL is task parallel library. So it actually does parallel processing. Means what? For example, if you spawn 10 threads, and let's say if you have 4 processors, right? If you have 4 processors in your computer, still all the 10 threads, have a processor affinity, a CPU affinity. So they try to run only on processor 1 or only on processor 2. And if you want to go and utilize your other other processors, then you need to go and write some code like this. You need to go and get the current process, and then you need to go and say, okay, processor affinity run on the second processor or run on the third processor. It is quite a big work, right? So when you use task, right, the TPL library, what it does is it actually looks at your processors and says that which of the processors are not loaded, and goes and runs those parallel code or the parallel logic into those processors. So TPL actually utilizes your processors. It actually does parallel processing. While threads, they have a processor affinity. They try to stick to a processor, making not really doing parallel processing, but rather than doing context switching or time slicing, right? So the first point which should come out in this difference is that tasks utilizes your processors. It utilizes your hardware properly, right? We don't have to write extra code for it, while threads have a CPU affinity. And the third P is plus, lot of plus. In case of task, I can return a result. In case of thread, I can't. If I want to get a result from a thread, I have to use delegates, or I have to use events and so on. I can cancel a task. I can chain task. I can wait for the other task to finish. I can use async and await, right? So TPL is nothing but it is actually, I will say, a wrapper, or I will say rather, it is an abstraction which is over threads, and it provides lot of things. First one, it provides parallel processing. Second one, it provides pooling. So rather than building from the scratch, the objects are taken from the pool. And then plus, lot of extra things it has. It can return a result from a parallel process. You can cancel a task, you can chain a task, you can wait for a task to finish, you can use async and await, and so on. So I would say that when you go before the interviewer, when you are asked such kind of questions, prepare your one-liners, speak to the point, make your answers crisp and clear. One of the things, during the TPL and the thread conversation, I would surely send to the interviewer is that in today's age, I will always use TPL, because TPL is a wrapper on the threads providing all these features, right? So why would I ever use threads? So in case I have a legacy code which is in .NET 2.0 or 3.0, it makes sense to use threads. But if you talk about .NET Core, or if you talk about the .NET 4.x any version, we would just use TPL and not the old threads. How are exceptions handled in C#? Now exceptions are handled by using the try catch block. So you can see here I have a very simple code, and in this simple code at this line, we are going to get an infinite exception, or I will say a divide by zero exception. So what you can do is that, in whichever places you will get an exception, you will go and you will wrap that place with try block. So you can see here I am expecting that in these two lines, I can have error. So I have gone ahead and I have wrapped them into a try block. Now if any exception happens, it will jump to the catch block, and in the catch block I can go and I can show some, I can go and I can decide what to do when this error happens. So for example, here I will say if exception happens, then just show divide by zero error, re-enter the value, right? So exceptions are handled by using the try catch block. So if I go and if I run this, you can see my application has handled the exception gracefully. If there was no try catch block, if you do not have a try catch block, what happens is, it just throws up the exception and it leaves it to the application to handle it. So if you see here, if the exceptions are not handled, the application just crashes like this, right? So exceptions are handled by using the try catch block. Another connected question, which comes over here is with the try catch is, what is the use of the finally block? So there is also something called as a finally block. Finally block is used, is the place, where you write the code which should execute irrespective you have an exception or you do not have an exception. So for example, in the finary block, probably you want to go and write some cleanup code, right? Some cleanup code, some memory cleanup code, and so on, right? So you can go and you can write that in the finary block. Now, irrespective you have an exception or you do not have an exception, this code will always execute. So for example, if I run this now, you will see that I get a divide by zero error, but also my cleanup code runs, right? Now, if I don't even have an exception, so for example, if I do not even have an exception, then also my finally block will run. So you can see I don't have the exception. It has not gone to the catch block, but the cleanup code still runs, right? So in finally block, we put that code which will run irrespective if there is an error or if there is no error. What is the use of out keyword in C#? When you talk about C# functions, when you write a C# function, it returns only one value. I repeat this. When you write a C# function, it returns only one value. But what if you want to go and return multiple value? For example, you want to go and return, in this case, you want to go and return an addition, right? You want to go and return a multiplication. You want to go and return a division. So you want multiple return values. Then you will use the out keyword. So what I can do out here is I can go and I can create an out, which is an addition, right? An out, which is a subtraction, and so on, right? And then I can say here addition is equal to this. And now I don't need a return type, means the output will be sent in these variables, and then I'll say subtraction is this. And then on the caller side, what we can do is we can go here and say, okay, this is addition. This will have the value of subtraction. And then we can invoke the mymaths function and we can say that whatever is the calculated value in this add and sub, please send it back to add here and please send it back to sub here. So you can see now I can return multiple values from a function. So the whole goal of the out keyword is to return multiple values from a function. A very big congratulations. You have completed 27 questions. A big congratulations for it. We have more 3 questions to go, right? So what I'm thinking is this video has already become more than an hour. So how about, I will go through these 3 questions theoretically in this part 1, and in part 2, I will show you the code demonstrations, right? So these are the 3 questions, which is flashed on the screen. So let us go through the answers of them. And in the next video, that is part 2, we will go and we will see the demonstration of it, right? So first question number 28, what is the need of delegates? Any C# interview does not get completed with a question on delegates and events, right? So here is the answer. Delegate is a pointer to a function, and it is very useful, when you talk about communicating between threads. So if you have a multi-threaded environment and if you say that you want to communicate between those threads, then delegate is a way to go ahead, right? So delegate is a callback. It is a pointer to a function to communicate between threads. Question number 29, what are events? Events are actually a wrapper over delegates. They are encapsulation over delegates. They ensure that, the delegates cannot be tampered by anyone. Events actually change the delegate to a publisher subscriber model. Events actually, change, the delegate to a publisher subscriber model, right? So events are encapsulation over delegates. Please note that whatever answer I'm giving here now, in part 2, I will show you in a practical way why the answer is like this, right? And to my best understanding, when you see something practically, you can grasp much better, right? So in part 2, we'll be going through 28, 29 and 30 again. Question number 30, what's the difference between an abstract class and interface? Abstract class is a half-defined parent class. So it comes in inheritance. So if you have many classes and if you have something common in between them, then probably it is good to go ahead and create an abstract class, a parent class, and put the common functionalities into the parent class. While interface is a contract. So interface is a contract and it has to be implemented. So interface, kind of forces a structure into a class, right? So this is what these three questions are. What is the need of delegates? It's a callback. It's a pointer to a function. What are events? Events are encapsulation over delegates. What's the difference between abstract class and interface? Abstract class is a parent class, a half-defined parent class, while interface is a contract. Now, before we wrap up this 1 hour of training video, I would like to quickly go through 3 tips. These tips will keep increasing. So as we do part 2, part 3, there are like 10 tips, which I'll be sharing with you gradually. Now in this 3 tips, first, the first 2 tips I've already discussed in the previous part of the video, but I will just iterate over here. Tip number 1, do not hit around the bush. Answer to the point. The interviewer does not have time, to listen to your whole saga and raga. So just answer to the point. Second tip, first thing first. So if somebody is asking you, okay, what is the difference between .NET Core and .NET Framework? Do not start saying, okay, .NET Framework is an old one, .NET Core is a new one. No, like .NET Core runs cross-platform. .NET Framework runs only on Windows. Say the important point first. Do not waste interviewers' time. And tip number 3, use the right technical vocabulary. Impress the interviewer by using polished and proper and right technical vocabulary. What does it mean? For example, if somebody asks you a question over events, someone can say, okay, events are a wrapper over delegate. Good answer, right answer, but not polished. But if somebody says events are encapsulation over delegates, events create a publisher subscriber model. Look at my answer. It's impressive, right? English is my second language. Let me tell you, English is my second language, but just because I know the technical vocabulary, I can impress the interviewer, right? So events are encapsulation over delegates and events helps you to create a publisher subscriber kind of an environment. Have the right technical vocabulary. For example, okay, what is a delegate? Pointer to a function. Callbacks. What is an interface? A contract. These are technical vocabularies, which spice up your answer, right? So I hope that you will remember these 3 tips out there. So that brings us to the end of our 30 questions. So as discussed, we have covered all the 30 questions in this video. Now very quickly, the last 3 questions, that is regarding the delegates, regarding the events and the abstract class and interface, I did not go too much in depth. What I did, I just went through some answers on the screen. I flashed it, but I did not show a demo. So what I'll be doing is we are going to have now more parts of the C# interview question. These are more advanced series and these series are all available on questpoint.com. So in the part 2, I'll be demonstrating what is a delegate, what is an event, in what situation we should use a delegate, what is the difference between delegates and events, and then I will also talk about abstract class and interfaces, right? So the part 2 of this series will cover events and delegates. So happy job hunting. Thank you and happy learning.